Hey guys, Daniel here. Hope you guys are doing well. Hope your revision's going even better. So just a quick intro for those who don't know me. I'm Daniel. This is my YouTube channel, Maths with Dan. I'm a GCSE and A-level maths tutor. And yeah, this channel, Maths with Dan, is just a channel really where I just put out maths videos essentially just to help you guys with your revision and obviously your exams, which are coming up very, very soon. And yeah, something new I'm doing this year are predicted papers. So this is my predicted paper for the Edexcel GCSE Maths exam foundation tier, which will be on the 15th of May. And yeah, the way I've constructed this paper is I've done a bit of research into the previous past papers, looked at what's come up and where, and just basically tried to replicate it by putting my own questions in here. So yeah, hopefully you find it helpful. I would recommend that you do the paper first before watching the video. So if you stumble across this video and you haven't done the paper, then the link to the paper is on my website, and I'll also put the link in the description, and I'll also pin a comment with the link to the paper as well. So yeah, it's gonna be an hour and a half. So just like the normal exam. So give yourself that amount of time. And yeah, that's pretty much it. Let's get into the walkthrough. Okay, so question one says write the number 4865 correct to the nearest hundred, 4865. So all you're gonna do is go to your column in between the 110th column. That number is a 6 there, so that 8 is going to round to a 9, so it's going to go to 4900. So it's going to be 4900. Question 2 says write 0.62 as a percentage. So to go from a decimal to percentage, you just times it by 100. So times it by 100, times it by 10 will be 6.2, times by another 10 will be 62. So the answer is 62%. Write the following numbers in order of size. Start with the smallest number. So when you deal with these types of questions here, what you'd always want to do is write them to the same amount of decimal places so you can actually see which number is greatest. So what I'm going to do is I'm actually going to write this with 2 zeros. The reason why is because whenever you put zeros after a decimal place, it doesn't actually change the number. And I can see that I've got 3 decimal places, right? For the largest amount of decimal places that I can see in any number. So I'm going to put them all to 3 decimal places. So I'm going to put 2 zeros there, and I'm going to put a 0 here, and I'm going to put a 0 there. And then now we just look at the numbers after the decimal place, right? So we start with the smallest number. What's the smallest number after the decimal place? It's 400, so it's going to be 0.4. That one is going to be number 1. The next smallest number is going to be 408, so the next number is going to be 0.408. And then put number 2 here. Next one is going to be 430, so that's 0.43. Let's put that there. And that'll be number 3. And then number 4 is quite clearly 500, so I'll put number 4 there, and that'll be 0.5. And the last one is 0.750, isn't it? So just 0.75. And that's it for question 3. Question 4 says write 417 correct to the nearest 10. Again, 417 to the nearest 10, we're going to go here. Now this number is a 7, so it's 5 or more, so we're going to round that 2 up, isn't it? So that's just going to be 4, 2, and then a 0, so it's just going to be 420. Now, question 5. It says write 20% as a fraction in its simplest form. Okay, so we're dealing with a percentage now. We will need it as a fraction. Remember, percentage just means you divided it by 100. So this is actually 20 divided by 100. And then simplifying that, well, we can cross out a 0. 0, 0 goes. That's just 2 over 10. And then you can simplify this just by dividing top and bottom by 2. That's just going to be 1 over 5. So this is just going to be a fifth. Part 6, question 6. It says simplify 5 times 2n. So all you've got to do here is remember when you're timesing by a number and an algebraic term, what I can do is I can bring these together. 5 times 2 is 10, right? And then you can just add the n on top, on next to it. So therefore, 5 times 2n is just going to be 10n. So that will go there. So you just times the numbers together and then put the letters after it. Now simplify this one for part B. 6b minus 2b plus 5b. So they are all in terms of b, so they're like terms. So what I would do first is what I like to do with these type of questions actually just get rid of the letters first so you can see what's happening, and then bring it back. 6 take away 2 is 4. 4 plus 5 is 9. So therefore this here is just 9b. So therefore the answer is just 9b. Okay, so we've done that one. Next one. Question 7. Write the following fractions in order of size. Start with the smallest fraction. So again, we're dealing with fractions and they've all got different denominators. When they have different denominators, it's difficult to compare them, right? When they have the same denominator, it's easy because you just look at the numbers on the top. So what I will do is look at each of these denominators here, and I'd ask myself, well, what would be the lowest common multiple out of all of these numbers here, right? And they all go into 12, don't they? Right? Every single number here goes into 12. So what I'm going to do is I'm going to make every single denominator a 12, right? So let me just use different colors. So I'm going to make each of these denominators a 12. So this one in the middle already has a 12. So that's going to stay the same. So it's going to be 4 over 12. And I'm going to put this over 12, put this one over 12, put this over 12, and then put that over 12. So going from a 2 to a 12, we're times them by 6. So the 1 has to be times by 6 as well. So that's going to be 6 over 12. 5 over 6, we're going to times by 2. So that's going to be a 10 over 6, 10 over 12. Next one is fine, done. 3 to 12 we're times them by 4, aren't we? So that's going to be 2 times 4, which is 8 over 12. And then this one we're times them by 3 to go from 4 to 12. So we're going to do 3 12s. Now, what do we have here? We have all of the numbers with the same denominator, so we could just compare them by looking at the numerators. Start with the smallest fraction, which has the smallest number here. This is going to be number 1. Next one is going to be this one. The next one's going to be this one. And then the next one's going to be this one here. Next one's going to be that one. So now that you've got your order, obviously I'm running out of room, I'll do it here. All you're going to do is just write them the way that they were given to you. So you're going to write 1/4. That's the first one. The next one was 4 over 12. It was already given like that. Next one's going to be 1/2. Next one's going to be 2/3. And the last one, which is the biggest one, is going to be 5/6. And that's it. Finished. Okay, so question 8 says Ali buys 2 bottles of juice costing £1.20 for each bottle, 1 packet of crisp costing £1.40, 4 chocolate bars. Ali pays with a £10 note. He gets £1 change. Ali works out that 1 chocolate bar costs £1.10. Is Ali right? You must show how you get your answer. This is 3 marks. Okay, so Ali pays with £10 and he gets £1 change. So the first thing that I would want to figure out is how much it cost him to buy all of these bottles of juices and crisps and chocolate bars, right? And that would be, I'm going to write total cost. That will equal the amount he paid. So I'm just going to write paid, right? Take away the change, wouldn't it? Right? Because you're paying a certain amount and you're going to get change back. So the difference would be how much it actually cost you to buy it. And how much you paid was £10. The change got was £1. So it cost him £9, isn't it? Right? He paid £10. He got £1 change. It must have cost him £9. So we know how much it cost him. So now we need to figure out the cost of the actual products that we do know, which is the bottle and the packet of crisps, right? So we know that one bottle, all right, B for bottle, one bottle is equal to £1.20. That means that 2 bottles is £2.40. So we know how much the cost of the 2 bottles were, and he bought 1 packet of crisp, and that 1 packet of crisps, I put 1C for crisps, that is £1.40. So we could work out the cost of these, right? So let's add these together and see what we get. £2.40 and £1.40. It's not too bad. That's just going to be 0. That's going to be an 8. That's going to be a 3. It cost him £3.80 for the 2 bottles of juice and the crisp, right? That means the remaining amount out of this £9 that he paid, right, must be the cost of the chocolate bars, right? So what we're going to do now to figure out how much the chocolate bars cost is by working out how much all 4 of them were, right? So we're going to say that the 4 chocolate bars, right, that will equal well, we know we have £9, right? So we're going to do £9 and we're going to take away that 380, right? And that will give us the remaining money for the 4 chocolate bars. So that would be, I'll do it here, 9.00, 3.8. That is 0, that's fine. I need to borrow 1 from there, so it's going to be 8. It's going to be a 1. 10 take away 8 is 2. 5 take away 3 is 8 take away 3, sorry, is 5. So the 4 chocolate bars cost 5.20. So I'm going to write this here. So the 4 chocolate bars is equal to 5.20. So I need to work out the cost of one chocolate bar, right? One chocolate bar. And that's not too bad. We can just use, I'll do it here. We can use the bus stop method, can't we? So I'm going to just say, because we're dividing by 4, aren't we? To get the cost of one chocolate bar. So we're going to do 4 into 520. Now 4 goes into 5 once, that's fine, with a remainder of 1, right? Point goes there. 4 goes into 12 3 times. So the answer is £1.30. So we now know the cost of one chocolate bar. One chocolate bar is equal to £1.30. And Ali said that he works out that it was £1.10. So Ali's wrong. So you're just gonna say Ali is wrong. That's it. Finished. Okay, so question 9 says the incomplete pictogram shows information about the number of apples sold from a market stall on Monday. Okay, and we've got it there. And then on Monday, the stall sold 12 apples. On Tuesday, the stall sold 16 apples. On Wednesday, the stall sold 18 apples. You use this information to complete the pictogram and the key, and it's 4 marks. Okay, so let's get started. So with this one, let me just zoom in a bit more. So what do we know? What information do we have? We've got the information for Monday. We've got the pictogram for Monday, and we've got the amount of apples sold, right? So what we can do is use that information to figure out the actual key and then work out Tuesday and Wednesday. So when I look at this, right, what I would do is I'll put these into quarters, right? I've got 1 there, 2, 3, 4, 5, and 6, right? I've got 6 quarters, right? So I'm gonna just say, for example, 6 of those things like that, right? This must represent the 12 apples. And now that I know that information, that will allow me to calculate what one of them must represent in terms of the apples, right? If 6 represents 12, then how do I go from a 6 to 1? We're just going to divide by 6, aren't we? Divide that by 6. 12 divided by 6 is 2 apples. So each of these represents 2 apples. And then what we can do is figure out what a full circle is, right? Because a full circle would have 4 of those quarters, right? So you would times that by 4, wouldn't you? Times that by 4, and that will give you 8 apples. So we now know the key, right? Which we can put here. So one full circle must represent 8 apples. So I'll put that there. And then now we can calculate the amount of apples, not even that amount of apples because we know, but the pictogram, we can complete the pictogram now. So Tuesday, the stall sold 16 apples, right? Well, if one of them represents 8, then 2 of them would be 16, wouldn't it, right? So I'll put that here. So I've got 1 there, like that, and then another one like that. Okay. Now, on Wednesday, the store sold 18 apples, right? So on Tuesday, there were 16, right? On Wednesday, there were 18. That's just 2 more, isn't it? Right? So how do we represent 2 apples? Well, 2 of them is just equal to 1/4, isn't it? So what we can do is say, well, on Wednesday, we're going to have 16. So we're going to have 1 there that represents 8 apples, another 8, which represents 16. And then we need 18 apples. So we need 2 more apples. So I'm just going to put 1/4 like that. And that would be it. That would give you the full marks. And that's question 9 finished. Okay, so question 10 says, write down the coordinates of the point A, right? So we've got the grid here. The point A is this one over here. The coordinates are going to be the X and Y. So if I go down to the X, that's -3. And then if I go across to the Y's, that's going to be 4. So the coordinates of A is going to be -3 and 4, right? X and then Y, isn't it? So okay, that's done. Part B says plot the point with coordinates -2, -3, and label this point C. So where is -2 on the x-axis? That's going to be over there. And then I'm going to go down to -3, which is going to be over here, isn't it? So this is going to be the point C. And I'll just label this -2, -3. So that's done. Part C says find the difference in x coordinates between A and B. Okay, so where is A? Where's B? Well, we know that the x coordinate of A, right, is -3. All right, let me write here x equals -3. The x coordinate of B, as we can see, is here is x is equal to 5. So the difference between them is going to be the largest take away the smallest, right? So it's going to be 5 take away -3. So it's going to be 2 negatives here. So it's going to be 5, I'll do it here, 5 minus -3. We know that 2 negatives make a positive, so it's 5 plus 3, which is equal to 8. So the difference in x coordinates between A and B is 8. Now, part D says draw the line with equation x equals -5. All right, so again, when you're drawing an equation of a line, right, if it's just x equals 2, right, you're going to go to your number on the x-axis. It was x equals -5. And you're just going to draw a vertical line through that number. So it's going to be like this. And then I will label this x is equal to -5. Now, when they're asking for an x value, then it's a vertical line. If they ask me for a y value, for example, let me just make this a bit straighter. Could be a little bit more straight or a little bit more vertical, I should say. Same thing. You know, it actually doesn't matter. Okay, got it. Yeah, if they asked you for example, y equals -5, right? Then what you would do is you draw a horizontal line through that number on your y-axis. So you would just put a horizontal line through -5 on your y-axis. So that's just something to remember. If it's x is equal to, that's a vertical line. If it's y is equal to a number, it's a horizontal line, right? Through that number on your axes. So that's done. Question 11 says reflect triangle A in the x-axis, right? So what do we have here? We've got a triangle A. Now, if I want to reflect it in the x-axis, that is going to be through this line over here. So it's going to flip on this side, isn't it? It's going to be on this side. So that point, right, would go there. This corresponding point will go down to here, wouldn't it? And then this point on top, right, would go at the bottom here, 3 units here because of the height. The height is 3. And then now, once you've got a couple of points, you can just literally draw the shape. And I've got ink to shape, so it will give me a nice triangle like that. And we could just label this B. In an exam, they probably tell you to label it anyway as well. So that's question 11. Question 12 says, we've got a number machine. The diagram shows a number machine. The input is times by 3, and then we add 4, and then we get the output. Part A says we need to find the output when the input is 5. So what that means is that I'm going to do 5, and then I'm going to times by 3, get something, and then when I get that thing, I'm going to add 4, right? And that will give me the output. So what would that be? Well, all that means is we're going to do 5 times 3 first, and then we're going to add 4 into it. So that's going to be 5 times 3 is 15, and then we add 4, that's 19. So that 19 would go there. And then part B says find the input when the output is 28. So when you're doing these types of questions where they give you an output, you need the input, you just reverse it. So let's just say the output is there 28. I'm going to go back on myself. And what that means is that you're going to do the opposite of what's happening when you're going from left to right. So because here I was adding 4, right? I'm going to have to take away 4. And then when I was here, I was timesing by 3. You're going to divide by 3 instead. So in that case, it's going to be 28. We're going to take away 4 first, which is going to give you 24. And then after that, you're going to do 24 divided by 3, right? Which is just, see, 24 into 3 into 24 is 8 times actually. Yeah, it's 8. So therefore, the answer is 8. And that is it for question 12. Okay, so question 13 says 4 kilograms of apples cost £3.20, 3 kilograms of apples and 4 kilograms of bananas cost a total of £5. Work out the total cost of 2 kilograms of apples and 3 kilograms of bananas. You must show all your working, and this is 4 marks. Okay, so firstly, what do we know? Well, what do we want to calculate? We want to calculate the cost per kilograms for each of the apples and bananas, and we know that 4 kilograms cost £3.20. So I'm going to write 4 kilograms, right? 4 kg is equal to £3.20. This is for apples. That means I could work out what 1 kg would be, right? And that would be, well, we just have to divide that by 4, wouldn't we? So if I divide that by 4, that's going to be 3.20. 4 doesn't go into 3, so I can put a 0 there. How many times does 4 go into 32? That goes in 8 times, doesn't it? So I can put an 8 there, and that's just going to be zeros. So the answer is going to be ATP, isn't it? So that's going to be ATP. Okay. So we now know the cost of a kilogram of apple. Now we're going to use that to figure out the cost of the kilogram for a banana, right? Because we know that 3 kilograms and 4 kilograms make £5 altogether. So 3 kilograms of apples, we're going to times that by 3, like that. So timesing that by 3, you could just think of that 80 as 8. 8 times 3 is 24. So that's just going to be £2.40, isn't it? Like that. So we now have £2.40 for the 3 kilograms of apples, right? Now, the total cost of the 3 kilograms and the 4 kilograms of bananas is £5. So what I could say is that the 4 kilograms of bananas, right? That is going to equal the total cost, £5, and we're going to take away that £2.40, the cost of the apples, right? So all we need to do is work out what that is. So what is that? That's just going to be 500, take away 2.4, like that. That's going to be zeros. Borrow 1 from there. 10 take away 4 is 6. 4 take away 2 is 2. So that's £2.60. So the 4 kilograms of bananas cost £2.60. And then I could use that to work out. Let me write bananas here. Let me write B for bananas. So we know that we're working with bananas. Now we can use that to calculate the cost of 1 kilogram of bananas, right? So what are we going to do? We're going to divide this by 4, aren't we? So dividing that by 4, again, you can just do whatever method you like. I'll do it here. 2.6, blah, blah, blah. 4 doesn't go into 2, so we put a 0 there. 4 goes into 26. How many times? It goes in 6 times, doesn't it? It goes in 6 times with a remainder of 2, right? 4 goes into 25 times. So that is just 65p. So that's going to be 65p. So now we know the cost of each of the apples and the bananas per kilogram. It says work out the total cost of 2 kilograms of apples and 3 kilograms of bananas. So what I'm going to do is I'll do it here. I'll just write A for apples like that. We know that 1 kilogram. Oh no, I just realized. No, we're fine. Yeah, 1 kilogram of apples was equal to 80p. So doubling that, 80p doubled is just going to be £1.60, isn't it? And then 3 kilograms for bananas, right? 1 kilogram of bananas is 65p. So therefore, 3 kilograms is going to equal, we're going to times that by 3, isn't it? So let me do that here. So we're going to do 0.65 times by 3, right? So we can just do, or just doesn't really matter to be fair, you can do whatever method you like. So we're going to do that there. That's going to be 15, so carry the 1. 3 times 6 is 18, add the 1, that's going to be a 9. And then put the 1 there, that's going to be £1.95. So therefore, that's going to be £1.95. Like that. So now we've got the cost of each of these. The cost of a kilogram, 2 kilograms of apples, £1.60. Cost of 3 kilograms is £2.95. So we're just going to add these together, aren't we? So it's going to be 1, I'll do the 9.5 on the top, plus 160 on the bottom. That's going to be a 5 there. 9 and a 6 is 15, like that. Carry the 1. And then we're just going to do 1 plus 1 plus 1, which is 3. So the answer is just going to be £3.55. And that's it. Finished. Okay, so question 14 says P is equal to 3x plus 5y, x is equal to 4y is equal to minus 1. Work out the value of P. Okay, so this is just substitution. We're saying that x is equal to 3 times x, right? That's what 3x means. Since x is 4, we're actually doing 3 times by 4 plus, and then 5 times by y. But y is minus 1. So all we're doing is just subbing in our values for x and y. So working each of these out individually, 3 fours are 12. 5 times minus 1 is a minus 5, isn't it? Right? So I've actually got a plus and a minus here, which is just a minus. So it's 12 take away 5, which is equal to 7. So the answer is 7 here. Now the next one, expand 2g, g plus 6 for 2 marks. Okay, so whenever you expand, you're multiplying out the brackets. So I've got to do 2g times g. That's going to equal 2g times g, which is going to be 2g squared. And then I've got to do 2g times by 6, don't I? 2g times by 6, that's going to be 12g. So the answer, you just bring these together now. They are being plussed, so it's going to be 2g squared 2g squared plus 12g. And that will be it. Now, part C, it says solve 4n minus 3 is equal to 28. Okay, so firstly, what you want to do is expand the brackets. So I'm going to do 4n minus 12, right? 4 times n is 4n. 4 times minus 3 is minus 12. This will equal 28. And then now I'm going to add on 12 onto both sides. So that would be 28. I'm going to add that on, plus 12, be 28 plus 12 there. 4n is going to equal, 28 plus 12 is 40. And then now to get n, we need to get rid of that 4. To get rid of that 4, we're going to divide both sides, aren't we? So it's going to be 40 divided by 4, so n is going to equal 10. And that is it. That is question 14 finished. Okay, so question 15 says work out 4.36 times 2.5 for 3 marks. So what I would do with this one is I would get rid of the decimals first, right? And then put them back after. So 4.36, I would change that to a 436, right? And that would mean I have to times by 100. 2.5, I'd make that a 25, and that means I times by 10. So we work out what this is, and then once we work that out, we have to reverse it, don't we? So let me work this out. Let me do it here. 436 times by 25. What do we get? 6 times 5 is 30, so I put a 0 here, carry the 3. 3 times 5 is 15, right? Add 3, that's 18, so I'm going to put an 8 here and then carry the 1 over there. 5 times 4 is 20, add the 1, that's going to be 21. So that's going to be like that. And then now I'm going to do the second digit, the 2. So because I'm doing the 2, that's the tens column, I'm going to put a 0 here. And now 2 times 6 is 12, so I'm going to put the 2 here, carry the 1, just here. And then now we're going to do 2 times 3, which is a 6. Add the 1, that's going to be a 7, isn't it? But that 7 will go here now. And then the last one is going to be 4 times 2, which is an 8, and that will just go there. And then now we can just add these together. 0 zeros are 0. 8 plus 2 is a 10. So I put a 0 there, carry that 1. 1 plus 1 is 2, add the 7, that's 9. And then 2 plus 8 is 10. So that will be a 0 and then a 1 there. So it's 10,900. So therefore, this here is equal to 10,900. But what did we do originally? We times by 100 and then we times by 10. So to reverse it back to get 4.36 times by 2.5, I have to reverse that. So I'm going to divide by 100 and I'm going to divide by 10, right? Which is overall just dividing by 1,000, isn't it? So to do that, what do I get? Well, you're just going to bring this decimal point there, 1, 2, 3 units to the left, isn't it? So it will now be at there when I divide by 1,000. So therefore, the answer is just going to be 10.9. And that is part A. Part B says work out 48.96 divided by 1.2. Now, the main thing with this one is actually, you just want to make sure your denominator is an integer, right? So I'm going to write out as a fraction 48.96, right, over 1.2. And I'm going to times top and bottom by 10. This is going to be an equivalent fraction. It's not going to change the answer. It's just going to make the denominator a whole number. So we can just use the Buster method a bit more easily. So I'm going to work out what this is instead of the actual question. These are the same thing though, aren't they? So I'm going to do this like that. 489.6 like that. And then I'll put zeros there. All right. So 12 doesn't go into 4, but 12 goes into 48 4 times, doesn't it? So I'm going to put that 4 over there. Now, 12 doesn't go into 9, right? So I have to put a 0 there. But 12 does go into 96, doesn't it? 12 going into 48 is 4. 96 is twice as big as 48. So it's going to go in 8 times, isn't it? So I'm going to put the point there. And then 12 going into 96 is going to be 8. So that's going to go over there. So the answer is literally just going to be 40.8. Because that is the same as working like that. So that's it. That's question 15 finished. So question 16 says Jacob wants to make some biscuits using this recipe. If you make 10 biscuits, you've got 100 grams of butter, 160 grams of flour, 40 grams of sugar. Jacob thinks he has 300 grams of butter, 600 grams of flour, and 160 grams of sugar. Assuming that these weights are correct, work out the greatest number of biscuits Jacob can make. You must show all your working. Okay. So for this one, we've got an ingredients to make 10 biscuits. So you can make a certain amount of biscuits for every batch, right? Which is 10. So what I'm going to say is I'm going to say that one batch, right, will equal, one batch will equal 10 biscuits. I'll write that for sure, right? Now we want to figure out how many batches we can make per ingredient, right? And then that will allow us to figure out how many biscuits we can make overall. So if I deal with the butter, right? In one batch, we have 100 grams of butter, but Jacob has 300 grams of butter, what he thinks he has, right? So we would need to figure out, well, how many hundreds will go into 300, right? So that would be the first thing that I would do. So for the butter, it's going to be 300 divided by 100 because I want to work out how many batches I can make just with the butter. And obviously that is just equal to 3, isn't it? So we can make 3 batches just with the butter, right? If we're just looking at the ingredients for the butter, right? Now, the next one is flour. So put F for flour. How many grams does Jacob think he has flour? He thinks he has 600. And we know that for every 10 biscuits, for every one batch, you have 160 grams. So I need to work out how many 160 is going to 600. Now, doing that, I can cross out a 0, cross out a 0. That's 60 over 16. And then I can actually divide top and bottom by 4, right? We can divide top and bottom by 4. That will give me 15 and that will give me 4. So now I need to work out what 15 divided by 4 is. So let's do that. We use the bus stop method. 15.0, blah, blah, blah. 4 doesn't go to 1. 4 goes into 15 3 times, doesn't it? Right? With a remainder of 3. 4 goes into 30 7 times because 4 sevens are 28. So it goes in 7 times with a remainder of 2. And then 4 goes into 25 times. So that means we can make 3.75 batches, right? For this one. Now for the sugar, sorry, S for sugar. How many grams of sugar does Jacob think he has? 160. How many grams do you need for one batch? 40. So you're gonna figure out how many 40s go into 160, and that is just gonna be 4, isn't it? Because that's just 16 over 4. That's gonna be 4. So we have 4 batches here. Okay. Now, for each ingredient, let's compare, right? For butter, we have 3 batches, right? For flour, we have 3.75 batches, and for sugar, we have 4 batches, right? What is the greatest number of biscuits Jacob can make? Well, surely each of these, the number for each batch should match, right? Now, we've got 3 here. Now here we've got 3.75. You can't make a fraction of a batch, can you? So that 0.75, we can't do anything with it. So we'd actually just have to make 3 batches here, right? If we're just looking at this contextually, right? Because it's just 3 and a bit more, but it's not 4 batches, right? So we can make at minimum 3 batches from the flour, and then 4 batches we can make from the sugar, right? However, these all need to match. So if we can make 3 batches for butter, 3 batches for flour, then this has to be 3 batches as well. So we're gonna bring this down to a 3, right? Now remember, whoops, hold on a sec. Now the question that asked for the batches, that's what I introduced. The question asked, work out the greatest number of biscuits Jacob can make. Now we know that for one batch, there's 10 biscuits. If I want 3 batches, then you're just gonna times it by 3. So therefore it will just be 30 biscuits. So the minimum number of biscuits Jacob can make is just 30. So I write 30 there with a circle. So we got that. Okay, so that's done. Now, part B says Jacob is wrong. He has more than 160 grams of sugar. Does this affect the greatest number of biscuits Jacob can make? Give a reason for your answer. Okay, well, remember, how did we decide what was the number of batches we could make, right? It was the smallest number, which is 3, right? This was a bit more, we had to bring it down. This was too much, we had to bring it down. So it was the butter that was the limiting factor, right? That was the factor that said to us that it has to be 30 biscuits, right? So with that being said, for the greatest number of biscuits to change, right, the butter would have to change, wouldn't it? We'd have to have more grams of butter. Since we're not changing the butter, right, he has more than 160 grams of sugar, it's not going to affect the final answer. So you're just going to say, does it affect the greatest number? No. We need more grams of butter to make more biscuits. Having more grams of sugar does not change anything. Something along those lines. And that's it. That's question 16 finished. Okay, so question 17 says James has a garden in the shape of a circle of radius 10 meters. He's going to cover the garden with grass seed to make a lawn. Grass seed is sold in boxes. Each box of grass seed will cover 47 meters squared of garden. James wants to cover all the garden with grass seed. Work out an estimate for the number of boxes of grass seed James needs. You must show your work, and this is a 4 marker. So with this one, it's a non-calculator paper, right? There's a keyword here, estimate, right? We don't want to actually use these values here, right? So what can we do? Well, we need to work out the number of boxes of grass seed James need. Well, one box, right? we know covers 47 meters, right? Now, in terms of an estimation, we can approximate this. We can round this to the nearest 10, right? Or to the nearest 5, right? And that would be one box would be equal to, right? 50, right? We'll use that number instead. Now, this is one area we've approximated it to. Now, the area, right? The area of this garden is a circle. The formula for the area of a circle is pi r squared, right? So we need to use this formula. Now remember, pi is actually equal to 3.14. But again, this is a non-calculator paper. You don't want to use that. So let's approximate this. Let's round this to the nearest whole number. This will be 3, right? So therefore, the area, we can say, is going to be equal to 3 times the radius, right, which is 10, squared, right? And this is going to be 3 times 100, which is just 300. So now we've got the area of the garden, we've got the area of the box, we've approximated both of them, we've estimated them. What we need to do is work out how many boxes we can get with these values here. So if one box we're saying is 50 meters squared, then how many boxes would we need, right, for 300? And all you're going to do to work that out is to work out how many 50s go into 300, right? You cancel that, 30 over 5 is 6. So the answer would be 6 boxes, right? So an answer for part A would just be 6 boxes. And that's it. And part B says, is your estimate for part A an underestimate or an overestimate? Give a reason for your answer. Well, think about it, right? We have a garden, right? The area, what did we do to the area? We rounded down, didn't we? So if you imagine it like this, you have an area, I'm going to write original, right? Original has an area like this. The radius was 10, right? So let me write that again. And then the estimate, right? We actually made it a bit smaller, didn't we? Because we rounded down, right? Because remember, 3.14 is actually, sorry, 3.14 approximates to 3, doesn't it? So we've rounded the overall area down because it's the actual area would be 3.14 times by 100, isn't it? Which is 314. So what I'm going to do, let me write that there so it's actually clear. So the actual area is going to be approximately 314. Our one, right? Estimate is 300. Yeah, so it's gone smaller. And then the boxes, right? The boxes, the box had an area of 47, and then our box had an area of 50, right? We actually made it bigger. So the number of boxes or a box in our estimated area would take up more room because we've shrunk the size of the garden and enlarged the size of each box. So there's going to be fewer boxes in our estimate than the actual amount, right? There would be more boxes covering. Let me write 47 here, and then write 50 here. There would be more boxes covering this area than in our estimated area, right? So what you're going to say is that it will be an underestimate. Be an underestimate, right? We rounded the garden's area down, right? And the area of each box up. So in reality, there will be more boxes covering the area. And that's it. Finished. Okay, question 18 says the table shows information about the daily rainfall in the town for 60 days. So we've got the rainfall here in this column and the frequency in that column. It says draw a frequency polygon for this information for 2 marks. So when you're drawing the frequency polygon, what you always want to do is you want to draw an extra column. And this extra column you're going to call the midpoint. And that is going to be the midpoint of the class width, the interval, right? So that's in the first column. So with that being said, all you're going to do is say, okay, we'll find the midpoint of 0 and 5 is just 2.5. To find the midpoint of any two numbers, you just add the numbers together and then half it. So between 5 and 10 is 7.5. Again, 5 plus 10 is 15. Half of that is 7.5. So 7.5, and then that will be 12.5. And then this one will be 17.5, and then that would be 22.5. And then all you do now is you're going to plot these like coordinates. So what I'm going to do is I'm going to put these on the axes, the midpoint. So that's going to be 2.5. That's going to be 7.5. That's going to be 12.5. And then that's going to be 17.5. And then that's going to be 22.5. And all you're going to do is just literally plot these as coordinates. So 2.5 and 15, where would that be? That's just going to go over here like that. The next one is going to be 7.5 and 12, which is going to be that's 10. This is 12 point, sorry, that's 15. So, oh yeah, it's just going up in ones. It's actually easy. 11, 12. So that would be over there like that. And then the next one's going to be 18. So 12.5 is going to be just 2 under 20, which is going to be like that. And then the next one's going to be 17.5 and 9, which is going to be like that, like that. And then this one, next one's 22.5, is going to be 6. So that's going to be, so that's over here, isn't it? That's going to be just 1 over 5, which is going to be over there. And then now you've done this, all you need to do now is just join them together. So what I'm going to do is I'm just going to get a nice line and then join them. So it's going to be like that. Like that. What I'll do, just because it's kind of difficult, I think I'll just, yeah, that's fine. And then I'll do another one. Just gonna join that one. That will be like that. And then let me just put this in like that. And then this one is gonna be like that. Obviously, in the exam, you'd have an actual ruler, wouldn't you? So you'd be fine. And then, yeah, last one's just gonna be uh like like that. And yeah, that's it. That's question 18 finished. Okay, so question 19 says the first 5 terms of an arithmetic sequence are 2, 5, 8, 11, and 14. Write down an expression in terms of n for the nth term of this sequence. So this arithmetic sequence here. So what you want to do to figure out the nth term is very, very simple. You firstly want to ask yourself, well, what is the terms going up or down by? In this case, the numbers are increasing, so we're adding, and it's going up in threes, isn't it? Like that. Threes quite clearly. So your first part of the answer is going to be a 3, and then you just put an n next to the number. Now, the next part is you ask yourself, well, what would the term be before the first? Well, when we're going to the right, we were adding 3. So to go to the left, you take away 3. So you're going to do 2 minus 3, right? This is equal to minus 1. And that number you just put next to this. So the answer is just 3n minus 1. And that's literally it. So you just figure out what the difference is, right? Put that difference next to n, and then figure out what the term before the first would be and put that number after. That's all you do to find out the nth term of an arithmetic sequence. Now, let's do question 20. Part A says work out 3 and 2/5 plus 1 and 3/8 for 2 marks. Okay, so with this one, firstly, these are mixed numbers. I need to change these to top heavy fractions. So I'm going to do 5 times by 3, right, which is going to be 15. We times them together, and then we add that 15 onto the numerator, right? 15 plus 2 is 17. So that becomes 17/5. And then the next one is 1 and 3/8. This one, we're going to do 8 times by 1, right? Which is just going to be 8, right? Let me just forget the times. Forget 8. Just put 8 times 1, which is 8, and then add that on to the numerator, which is 3. That's 11, so it becomes 11/8. So what we're actually working out is 17 over 5 plus 11 over 8. So now, what do we do from here? Well, we need to get a common denominator. How do we do that? We find the LCM of the denominators. 5 and 8 LCM is just timesing them together. 5 times 8 is 40. So I'm going to make this 40. I'm going to make that 40. And then now we're going to ask ourselves, well, how do I go from a 5 to a 40 we times by 8? That means I've got to times the 17 by 8, isn't it? So let's just quickly do that. I'll do that here. 17 times by 8. That's going to be 7 times 8 is going to be 56. So I'll put a 6 here and then carry that 5. 8 times 1 is 8. add the 5, that's going to be 13, isn't it? So it's going to be 136. So it's going to be 136 over 40 plus, and in this one, to go from 8 to a 40, we times by 5. So that means we have to times that 11 by 5, which is just easy. It's 55, isn't it? So now we've done this, we can now add the fractions together. So I'll do that here. They've got the same denominator now, so I can put the numerators together. 136 plus 55. That is just going to equal 136 plus 50 is 186. Add 5, that's going to be 191. So the answer is going to be 191 over 40. Now, it doesn't say give it as a mixed number or anything like that, so we can just leave it like that. Now, part B, it says work out 2 and 1/3 divided by 5/6. Give your answer as a mixed number in its simplest form. So this one here, firstly, what we've got to do is we've got to change that to a mixed number. Sorry, we've got to change it to an improper fraction. So doing that again is easy. 3 to 2 times that is going to be a 6. Add that to the top. 6 plus 1 is 7, so it's 7/3. And then that just means that the question is just asking 7/3, right? Divided by 5/6. What do we do from here? Okay, well, remember, we're dealing with a fraction and we're dividing by another fraction. It's going to be keep, change, flip, isn't it? Right? Which means that we keep the fraction the same, the first one. We're going to change this division to a multiplication, and then we're going to flip the fraction, so it becomes 6 over 5. So now we just need to work out what this is. We times fractions by timesing them across. 7 times 6 is 42 over 3 times 5, which is 15. Now, it does say give the answer as a mixed number in its simplest form. So firstly, let's simplify, or you could do it as a mixed number, whatever you prefer. I'll simplify first. What do we know goes into both 42 and 15? That's going to be a 3, isn't it? Yeah. 42 divided by 3 is 14, and 15 divided by 3 is 5. Now we've got the simplified version. We can put this in a mixed number. How many times does 5 go into 14? How many times does the bottom go into the top? 5 goes into 14 twice with a remainder of 4, right? So the answer is going to be 2 and 4/5. And that will be it for question 20. Now let's do question 21. It says, find the highest common factor of 124 and 186. So what you want to do is you want to do factor trees. So 124, like that. This is an even number. This is just going to be 2, and that's going to be 62, isn't it? Like that. And then again, this is even. That's just 2 and 31. And then the next one is 186. Doing that one, this is going to be 2 and 186. 180 half is 90. 6 half is 3. It's going to be 93. And then this one here, you can see that there's going to be a factor of 3, isn't it? If I divide this by 3, 9 divided by 3 is 3. 3 divided by 1 is 3. 3 divided by 3 is 1, so it's 31 here. And then obviously that will be a 3, isn't it? And what I'll do just to be actually nice, so it's just nicely structured, I'll put the 3 there and the 31 there. Now that we've got our factor trees, let's write these in prime factorization form. 2 times by 2 times 31, and 186 is 2 times by 3 times 31. Now, to find the highest common factor, all you're going to do is draw a Venn diagram with your two numbers. So let me just bring this in a bit. Whoops, let me bring this in. Perfect, okay? And then now, it's going to be 124 there. It's going to be 186 there. Now, what is the middle number, right? Or numbers? Well, we look at our prime factorization. What do they both have in common? Well, they've got a 2 and a 2 in common, so I can put a 2 in the middle. They also have a 31 and a 31 in common, so that can go there. And then now the 2, right, isn't common in both. That will go on the outer side, the outer part of the 124. That would go there. And then this 3 would go there within it. So now the Venn diagram is done. To find the highest common factor, all you do, and it's always the same thing, you just times all of the numbers inside the middle, the overlap. So the answer is going to be 2 times 31, which is just 62. So the highest common factor of 124, 186 is 62. And if they asked you for the lowest common factor, lowest common multiple, you would times all of these numbers together, and that will give you the answer. But yeah, that's it. So that's question 21. Let's do question 22. Okay, so it says the universal set from 1, 2, 3, 4, 5, all the way up to 12 is that, and the set A is multiples of 3, and B is prime numbers, right? Part A says complete the Venn diagram for this information. So what you want to do when they give you these types of questions, these Venn diagram questions, This one here, it's descriptive. The sets A and B are descriptive. What you want to do is actually work out what the actual values are, right? So multiples of 3, what are they? And it has to be in the set, isn't it? The universal set on top. So obviously it's going to be a 3 first, and then it's going to be a 6, and then it's going to be a 9, it's going to be a 12, and then you just keep adding threes. Now, B, the set of prime numbers, you've got to be very careful here, because remember, what is the definition of a prime number? A prime number has two factors. It has the factor 1, right, and the number itself. So there's two factors. So 1 technically isn't a prime number. So I'm not going to put that in my set for B for prime numbers. So I'm going to skip that one. And then we just keep going. So 2 is a prime number. It's got the factors 2 and 1. So is 3. So is 5. So is 7. So is 11. Right? And these are going to be our factors, right? Or our set of numbers, right? So we've now changed the sets from descriptions to actual numerical values. So what do we do now? Let's complete the Venn diagram. Well, what numbers go in the overlap? Well, I can see I've got a 3 and a 3 there, and that seems to be the only number that's common in both. So I'm going to put a 3 in the middle. And then based on that, I can do the others. So set A, what numbers did we include in the overlap? 6, 9, and 12. That would go there. For B, prime numbers, what numbers did it include in the overlap? 2, 5, 7, and 11. That will go there. Now, are we done? Absolutely not. Remember, when you're doing Venn diagram questions, this is your point of reference. Every single number here must fit on the diagram somewhere. So you need to ask yourself, have you used every single number? Well, let's look at the numbers that we have used. We've used a 2, you can cross that out. We've used a 3, cross that out. We haven't used a 4, I'm going to skip that. We've used a 5, we've used a 6, I can see. We've used a 7. We haven't used an 8, so I'm going to skip that. Let me just underline the ones that we haven't used. We haven't used a 1 either, right? We've used a 9. We haven't used a 10, but we have used 11 and 12. So these numbers, 1, 4, 8, and 10, where would they go? They will go on the outside of your Venn diagram, or on the outside of the two circles. So it'd be 1, 4, 8, and 10. And that would be your completed Venn diagram question. So make sure, make sure you don't forget to do the outside. Now, part B, right? This is a typo, by the way, but it won't be when you guys get the paper. So don't worry about that. That's part B. It says a number is chosen at random from the universal set E, right? Find the probability that this number is in the set A and then that symbol B. Now that symbol, remember, that symbol means union, right? And all that means is that if I've got the set A union B, it means that I'm actually just looking at everything in the middle plus the two outer parts of the circle. So that's what I need to look at when I'm looking at A union B. So if I want the probability of choosing a number from this set, well, how many numbers do I have inside here? Well, let's count, right? We've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 numbers there. So the probability, which I can call this there, probability is going to be 8. And out of how many numbers? Well, how many numbers are here? So we had 8 in the green. This is going to be 9, 10, 11, and 12. And remember as well, it goes from 1 to 12 anyway, so you could have just looked at that. So the answer is going to be 8 twelfths. Now, when they ask you for probabilities, you actually don't need to simplify unless they say, but they never do. So 8 twelfths is fine, but if you want, you can just divide top and bottom by 4 to simplify it. And that would be 2 over 3. So any of these answers, 8 twelfths or 2/3, would be perfectly fine in the exam. And that's it for question 22. Let's do question 23. So it says, here are 6 graphs, right? It says, write down the letter of the graph that could have the equation for part A, y equals x squared. So this one here, you just got to have a good knowledge of your graphs because this question does come up quite a lot, doesn't it? So what does the graph of x squared look like? Well, we should know it actually looks like a U shape like this, right? It looks like this when you have a positive x squared, or it can look like this when you have a negative x squared, right? So to answer the question, it's going to be A, right? It's going to be A for the first one. And then for the second one, it says y equals 2x plus 1. Now ask yourself, what type of equation is that, right? You should know that this is just an equation of a line, right? This is an equation of a line, right? And the general formula for the equation of a line, right, is y equals mx plus c, right? Where m is your gradient and C is your y-intercept. So with that being said, we can see that follows that structure. So it's definitely a line. There's only one line out of the options here, so it has to be E, right? And yeah, that's it for question 23. Okay, so question 24 says, for part A, complete the table of values for y equals x cubed plus 5. We've got the table here and we've got the values of y that we need to fill in. So this is just substitution. Remember, what you're doing with a question like this is you're just literally plugging in your values of x to figure out what the corresponding values of y are. So what I'll do is I'll just do this on the side because there's just a bit more room. So I'll do it here and then I'll put the numbers back in after. So what do we have? So firstly, x equals minus 2 is the first one. X equals minus 2 is the first one. That means I'm going to do y is equal to minus 2 all cubed plus 5. Now, what is that equal to? Remember what minus 2 all cubed means. That means you're doing minus 2 times minus 2 times minus 2, and you're adding 5 after. What is that equal to? Well, let's start with the numbers. 2 times 2 is 4. 4 times 2 is 8. So there's an 8 there. Then we have 3 negatives. A negative times a negative will be a positive. But then we're times by another negative. So it's going to be negative overall. So it's going to be minus 8 plus 5, right? Which is going to equal a negative 3, isn't it? So therefore, that one is going to be a negative 3. The next one is x is equal to 0. This one I think is probably the easiest one because we're doing 0 cubed plus 5. And that is just 0 cubed is 0 because you're just timesing 0 by itself 3 times. And then you're just adding 5. So it's going to be 5 there. And then this one, x equals 1, slightly easier than minus 2, but not as easy as 0. We're doing y is equal to 1 cubed plus 5, which is going to be just 1 cubed. 1 times 1 times 1 is just 1, isn't it? So it's just 1 plus 5, which is equal to 6. So that would go there. And then x equals 2 is going to be y is equal to 2 cubed plus 5. Like that, right? And then now, well, we're just doing 2 times 2 times 2 again, isn't it? But without the minuses. We know that all of that is going to be 8. So it's 8 plus 5, which is equal to 13. So therefore, we can put a 13 there. And then now we can put those in. So it's minus 3, 5, 6, and 13. Minus 3, 5, 6, and 13. These are our answers here. Now, part B says on the grid below, draw the graph of y equals x cubed plus 5 for values of x between minus 2 and 2. So we should have plot the coordinates here, don't we? So the first one is minus 2, minus 3, which is going to be over there. Let me just put this in. I need to zoom in a bit, don't I? So we can get the actual questions. Whoops, I've gone all the way down there. Give me a second. Let's go back to where we were, which is over here. Fantastic. So because we need 3, we just need to be a bit careful here. So minus 2, minus 3 is the first one. Minus 2 is there. Minus 3 is going to be bang in the middle of minus 2 and 4. Minus 2 and minus 4, which is going to be over here, isn't it? It's going to be over there. That's going to be the first point. I'll mark with an X like that. That's minus 2, minus 3. And then the next one is minus 1, 4, right? X equals minus 1 and y equals 4. So x equals minus 1 is there. 4 is right there. So it looks like that. And then the next one is 0, 5, which is going to be x equals 0, 5 is going to be in between 4 and 6, which is going to be over there, like that. And then the next one is going to be 1 and 6, right? So x equals 1, y equals 6 is going to be over there. And then the next one's going to be 2 and 13. So 2 is there, 13 is going to be in between 12 and 14, it's going to be over there. So now we've plotted the points to actually draw the curve, right? We just need to join these together. And it's a curve, as I said, so you need to make sure it's like a nice, smooth type of transition like that. And then just continue it like that. And then obviously it's a bit difficult with this, but yeah. And that will be it. That will give you the answer for question 24. I'll just label it as well. Why not? Y equals x cubed plus 5. Perfect. So that's question 24 done. Let's do question 25. So question 25 says, work out the value of 3 to the minus 6 times 3 to the 10, all divided by 3. So when you see a question like this is just a matter of index flows, isn't it? So what do we do here? Well, firstly, if you look at the numerator, we've got a number times a power times that same number to another power. So we're going to use our index flow that says a to the b times by a to the c is going to equal, remember, you add the powers together. So therefore, if I've got 3 to the minus 6 times by 3 to the 10, that's just going to be 3 to the power of minus 6 plus 10, isn't it? And that there, we can work out, that's just 10 take away 6, isn't it? Which is going to be a positive 4. So therefore, the numerator is 3 to the 4. So that means that the actual question itself is just asking to work out what 3 to the 4 is. So let me write that for a bit better. 3 to the 4 divided by 3, right? Now, how do we work this out? Well, remember, 3 with a power is going to be a 1 there, isn't it? Now, we're dividing these now instead of timesing. So there's another rule we need to remember. A to the B over A to the C is just A to the B take away C. So that means that this here is just 3 to the 4 take away 1, which is just 3 to the power of 3. Now, it says work out the value. You can't leave it like this. So what you need to do is actually evaluate this. That is just 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is 27. And that's your answer for question 25. Now, we've done that. Let's go to question 26. So it says Gabriella has 2 bags, right? In the first bag, there are 4 red balls and 6 green balls. In the second bag, there are 3 red balls and 5 green balls. Gabriella takes at random a ball from the first bag. She then takes at random a ball from the second bag. Complete the probability tree diagram. So they've given us a bit. So what do we have here? Well, we have the first probability for red would be 4 out of 10. And that makes sense, doesn't it? Because how many balls do we have in total for the first bag? It's going to be 4 plus 6, which is equal to 10. So it would be 4 tenths, isn't it, for probability for a red ball. So for a green ball, it's just going to be 6 tenths, isn't it? Right? Because they have to add to make 10. This one is 3 over 8. That makes sense because again, 3 plus 5 for the second bag is going to be 8. So it's 8 in total. So it's just going to be 5/8 for this one. And then this one is just the exact same, isn't it? So that there. Perfect. So we've done that. That will give us 2 marks. Part B says work out the probability that Gabriella takes 2 red balls. Well, when you're dealing with probability trees, you just look along the trees. If I'm going to write probability for P for probability, 2 reds, right? That means if I look at my diagram, I'm just going along the red branches. So red is there and then red is there. And then what you do is with these probabilities, you just literally times them together. So therefore, the probability of you getting 2 reds is going to be 4 over 10 multiplied by 3 over 8. How do we times fractions together? You just times across. So it's going to be 12 over 80. Now, again, as I said before, you don't have to simplify unless they specify it, but they never do. So you can leave it as 12 over 80, which is fine. Or you could just divide the top and bottom by 4, isn't it? That will be 3. 80 divided by 4 is 20. So the answer is 320. So it could be 12. You could either put 12 over 80 or 3 over 20. Either one of those is absolutely fine. That's question 26. Now, question 27, the last question of the paper, right? It says solve x squared minus x minus 72 is equal to 0 for 3 marks. Okay, so how do we do this? We're solving an equation. That's the first thing. Now, whenever you're solving an equation, guys, right, you should always ask yourself, what type of equation am I solving? Because for different types of equations require different methods of solving, right? So what type of equation do we have here? Well, the indicator for me is the powers, right? Or the power. There's a power of 2 here. Now, this is a power of 1, isn't it? Right? Now, because that's a power of 2, right? That is the highest power. Any equation where the power is 2 and that's the highest power is a quadratic equation, right? So this is a quadratic equation. And the way you solve quadratic equations, right, is by factorizing. So we need to factorize this quadratic. Now, how do we factorize quadratics? Let me write it out. How do we factorize? Well, the way you factorize is you need to look at 2 things. You need to look at the number at the end, which in this case is a 72 with a minus. Do not forget that minus, guys. That minus is part of the number. Any symbol or any minus or plus to the left of your number is part of it. So I need to look at this number here. I need 2 factors of this number that when I multiply it, I get this number here, right? Sorry, that when I add them, I get this number. So I need 2 factors of minus 72, that those 2 factors, when I add them together, I get that number. Now, the thing is with this one is that there's not actually a number there. It's just a minus. But remember, that's an X. That's actually just a 1. So that number is actually minus 1. This is the trickier types of questions, which is why I put in the paper. So what do we do from here? Okay, well, we need to list our factors of minus 72. So what factors do we have? Well, it's negative. So I know that one's going to be negative, the other one's going to be positive. So we could say maybe 1 and 72, minus 1 and 72. You could also alternate it as well. So you could do 1 and minus 72. You could do minus 2 and 36 as well, which would be this one swapping over now, minus 2 and 36. Any others, of course, we could just do, what could we do? We could also do 4 as well, because that would just be minus 4 and 18. And that would be a positive 4 and a minus 18 as well. And obviously, 73 goes into it as well, doesn't it? That would be, what would that be? 70, 12, 60. You could just use the bust up method, to be honest. Can't think right now. 3 goes into 7 twice with a remainder of 1. 24, of course. Perfect. So we're gonna have minus 3 and 24, and then obviously 3 and minus 24. And then yeah, you could list the factors. The factors for this one, remember they need to add to make minus 72. The factor that you're going to need is just going to be a 9 and an 8. But what would the order be? So it could be minus 9 or an 8, or it could be a positive 9 and a minus 8. You need to make a minus 1, don't you? So with this one, if I add this together, minus 9 plus 8 is a minus 1. So that one works. This one will give me a positive 1, wouldn't it? And we don't want that. So it's going to be this one. So now that we've got the two factors that we need, minus 9 and an 8, right? All you're going to do is say, okay, well, fine. To factorize it, you're going to put 2 brackets here. And remember, it's equal to 0. You're going to put x here and x there, just due to the fact that we've got x squared. So when I expand that, I'll get x squared. So that's fine. And then all you do is just put those two numbers in, minus 9 and a plus 8. So now you've factorized it. What do you do here? You just set each of these things inside the brackets equal to 0 and then solve. So let me do that there. It's going to be x minus 9 is going to equal 0. That means x is going to equal 9, right? Or x plus 8 is going to equal 0. That means x is going to equal, move that 8 over to the right. We're going to take 8 away from both sides. So it's going to be minus 8. So your two answers are going to be x equals 9 or x equals minus 8. And another thing as well is for your exam anyway, these are the type of quadratics you will get. Once you get to this step, just literally flip the signs. X equals positive 9, x equals minus 8. And that is it. You can do that as well. And yeah, that's it. That's question 27. And that is the paper finished. Hey guys, Daniel here. Hope you guys are doing well. So yeah, that's the paper. Hopefully you found it helpful. If there were any tricky bits in it, I'm hoping that this video has clarified that for you, and you've picked up a couple of tips here and there for your exam, and you feel in a better position. That's the main thing with these papers. So yeah, that's amazing that we made it to the end. I will be doing a paper 2 and a paper 3 at a later point as well. I'll do paper 2 after paper 1, and then paper 3 after paper 2. And yeah, we're in this together. As well as that, I also will be running some extra classes throughout the exam season. I do classes every week anyway, so keep an eye out for that. And there's also obviously a lot of information on my website. And there's another thing I wanted to say. Yeah, I also have some courses as well that I'm really excited about that you guys may be interested in doing as well. So have a look out for that as well. And yeah, again, great to have you on the channel. If you found the video helpful, then it would be much appreciated if you could like, comment, subscribe, share with any of your friends or anyone that you think would benefit from these videos. And yeah, again, you're doing very, very well. Keep it up. Super proud of every single one of you. And yeah, you guys will be fine. But yeah, good luck for paper 1, and I'll see you guys soon. Take care.